Let's wait for a few more minutes to sort of get people on board and then we can start.
Yep.
Did you look at the Tawny Owl stuff? It was interesting, but I think it's just misclassification.
It is a misclassification. So the
Yeah.
main idea is when we see the column habitant and non-habitant, when
Yeah.
is the non-habitant, it means it is a misclassification. It can be like any type of any species
Yeah. I think it's
classified.
just variegated laughing thrush because I was looking at other Tawny Owl calls on Xenocanto library, and some of Tawny Owl calls have laughing thrush calling in the background. I think it's just I think they use those calls to train the model.
Yeah, yeah. Anyway, we started to build our model with Vanessa this week. So like we are like, kind of wrapping up the analysis. Like we sent you the report, the looker dashboard, also the mapping. So like right now we have to make sure like which confidence level we should to pick up to make a deeper analysis. And we already on the way to build the model. And like just
Yeah.
like few minutes ago, I cut audio files into like 3-second chunks so we can just train our model um, on Xenocanta and iNaturalist data because we found out we have more data on iNaturalist. And basically, when we split into calls and buzzes, probably we will try to verify if it's true. So we'll send you all the files. I mean, we shared the files, so just to double check if we classify them right, like as a buzz or as a call. So, and
Yeah.
if you say, okay, it's all right, we off to train the model.
Great. Awesome. Can you walk us through the confidence level document that you shared yesterday? I didn't quite understand it.
Absolutely. 1 second, please.
Thank you so much.
Mm. So, okay. Probably not. Okay.
Are these
So,
photos from Google Maps?
so
Somebody
this
else?
is this is from Google Maps actually. It's because like I like so this is all the locations like for the audio mouse and for the nest. Like
Yeah.
and also I've just now like I went to Google Maps and just got all these pictures and I figured out that's the area where
Yeah.
where's the
It's on
that's
the right side of it. Yeah. Yeah. Yeah.
yeah that's the
Exactly.
field area.
Yeah.
Yeah, so it was interesting because I just was trying to understand like where the field is, and I've got some pictures. I mean, that's
Yeah.
awesome.
That's the road I walk daily to get into that forest. The trail that you see here, the rocky trail.
Yeah, 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 yes, yes,
Yeah.
right here, yes, right.
Yeah.
Yeah, so it just goes like it goes this way, then uh runs the mountain, the hill,
Yeah,
and yeah,
then you walk down in the valley, then again start climbing up. There's a small bridge on the river further down the valley.
yeah, okay.
Yeah. It's just
So
like
yeah,
sheet of metal on a river with like two poles. There's no fancy bridge. It's barely you can get across.
yes, and I saw that there is some retreat in this area. Like some people are coming to this area to retreat, like do some spiritual stuff. So it looks
Yeah, yeah,
awesome.
yeah,
Okay, so we go to the observations, right? So uh, that's the total numbers of the observations read. That's so we start from zero point 0.5 confidence level, and we see like from all more than 200K, it goes down like to almost zero when the confidence level is zero. So what is the confidence level? Confidence level or probability is it is the probability of defining a class. Let's say if we see the confidence level zero point 0.9, it means there is 90% of probability that this is classified right. If let's say it's zero point 0.5, it means that's 50% of probability that this species is classified right. So the higher confidence level, the more probability of being classified right. That's the main point of the confidence level. And in our case, we have to choose the appropriate confidence level, like basically trade-off, where we can get enough genuine data and still having some numbers of misclassifications, like trying to get like just to make a decision on the trade-off. And in this case, we are having these two plots that could be a huge help to make a trade-off. So pick the confidence level. So let me describe what these plots show to us. So basically, we are like rate of change. So we are trying to see what is the change of numbers when we level up our confidence level. So in this case, let's say like the blue one, non-habitant rate. It's going like upward, like slowly, and it means that with the lifting the confidence level, the number of changes is getting down, but still like we have some numbers. And in case of green and red lines, habitant rate and total rate, we see like uh, the rapid drop actually at 0.85 and it starts at 0.75. So it means like we are losing like in this 500K means like we are losing 50K of observations within zero point 0.1 confidence level. Let's say so here we lost 50K observations. So that's a lot. So and that could be like a show for us, a sign for us to probably choose between zero point 0.8 and zero point 0.5. Well, I'm sorry, 0.8 and 0.85. And the second plot, it is the acceleration. So like how the change is like accelerating, the speed of change. And we see like, let's say like in case of non-habitant, uh, no matter what is the confidence level, the speed of the change is almost the same. And it is positive. It means it is very slow. When the acceleration is negative, be below zero, so it means it's speeding up. And it speeds up after zero point 0.8. So it means after zero point 0.8, we are losing a lot of genuine data. That's like that is the help for us to understand what's going on with all the observations at different confidence level. And when we go to the oh yes, 1 second. So yes, and this is just uh, pi plus to show us how many habitants. But habitants, we understand all the species that are in the specific area, and non-habitants at different confidence levels. So, and we see that at confidence level 0.9, the model is predicting better because we only have 4.3% of non-habitants. But basically, at the same time, the total number of the observations is also down. And here, just like now, it's just like it's not a proper chart, but it's just like to make a decision and see like what's going on. So let's say at confidence level 0.5 at the elevation at the low elevation, because we have low, medium, and high. So we have that many audio moths, and so we have 95K of habitants that are classified by the BirdNet. And here we can see like all the numbers by a specific name. So and we are classified 38 species. So like even like Asian house martin, like once. And then if we click on the location, let's say PSL6, so it shows us how many observations we got at this audio mouse. So look and see like, yeah, and we have like 25 at PSL6, and we can go to PSL2, yes, which is the biggest one. Yeah, the numbers are quite different. So that was the main point to show you, yes, and this is the proportion of um, habitants and non-habitants. So just showing that at the low elevation, we have around 94 percent of habitants, which is quite high because at the medium, I mean, in general, the proportion is different and kind of same at the high elevation. So in this case, we just go through all these confidence levels and try to see the whole situation. That was the main point of this dashboard, to show you what's going on. And Pranav, you ask us like to provide some data, what's going on at the specific location at the specific confidence level.
Yeah.
That's great. I wanted to chime in briefly because I wanted to join today, but I'm gonna have to leave in a couple minutes. My son just got back from school. But so this seems good. So it seems to me that what needs to happen now is for and I put a link to a paper here that in the chat that talks about the BirdNet confidence scores, because like Andrea was saying, the confidence scores, a lot of them are pretty low. And then you were describing kind of the distribution of confidence scores. And so what we need to do now is to get from the confidence score to a probability that it's labeled correctly. Because the BirdNet doesn't know. It ascribes its confidence score, but it's not actually a probability. So to do this, my suggestion is to have is to randomly sample across the confidence score range from say 0 to 1, and we'll pick like 50 or something like 50 recordings and send them to Pranav, just those sampled recordings, and Pranav can label them as correct or incorrect. And we can fit logistic regressions to see at what confidence score for a given species are we confident that it's correctly labeled. And so I've done this for a couple different species, a couple different BirdNet data sets before, and I think it works pretty well. And the end goal here is to be able to say, okay, like what confidence score will we accept for Hume? Is it 0.8? Like 0.8 is probably everything above 0.8 is probably correct, but it's possible that like everything above 0.6 is correct. And if that's true, like you were just showing, Andre, there's just a ton more data if we can figure out what that threshold is where we're confident it's correctly labeling it. So I'm gonna I'll stay on for a couple minutes here, but that's what I think should happen next.
Yeah, so you're right. So like the confidence levels says how confident we are that this is classified right or not right. So and basically when you run through the confidence levels, let's say if you run like let's say on 0.5, so 0.5 confidence level includes all above, like 0.6, 0.7, 0.8, 0.9. And in this case, if you run like a 0.5 up, so it has like, let's say 100K. If you just go from 0.7 to 1 point, it might have like 70K. So you're just eliminating all the confidence levels below. So in this case, yes, it is like how are we confident in terms of the classification? Yeah, so
exactly. And so my point is that at this point, now that you've looked at the data, you've mapped it, you've seen which species are showing up, which Pranav can probably make sense to you. It probably means BirdNet's doing a pretty good job. But now I think it's important to have I mean, probably everyone can do it. Pranav could probably just do it really, really quickly to like listen and be like, yep, correct, yep, correct, yep, correct, no, not correct. Uh, and the way to do that is to like, it's obviously impossible to sample these thousands and thousands of labels to assess them with expert knowledge. But even just taking like a like 50 or even for Humei, maybe we do 100. Like Pranav can listen to those really, really quickly and just say correct or incorrect. And then we can plot correct or incorrect against the confidence score and see if it a logistic regression there and see at what confidence score are we, say, 95% 95% probability that it's actually Humei. And
So
that way we tailor it to the actual data, and that will be important for a lot of the downstream things.
are we talking about only Hume's Warbler right now, or like in general data set?
Yeah, I think there's kind of two levels things. I think we should try to do this for all the species, but then for Humei, maybe we do it a little bit more in depth because it's the main one that Pranav has been studying.
Okay.
But with like 30 species and some of those species, right, don't have very many detections, so we'll basically just ignore them. But there will be, a main set of species that have a bunch of bird net detections. And then we can I'll send Pranav an email of what I'm thinking of as the methods that he can share with you all. And then we can get that basically have Pranav quickly listen to a bunch of recordings and label them as correct or incorrect.
So Ben, currently we have 15-minute recordings. So each recording is 15 minutes. And Andre yesterday randomly sampled 10, 15 minutes recordings and then
10. Yes.
ran through BirdNet, and we have that data now. So is 10 good number because it's 15 minutes each?
So what I'm talking about is so BirdNet for Hume, I don't have the file that you shared, but like BirdNet for Hume gives how many detections? Like thousands and thousands, right? And then those come from a variety of confidence scores. A lot of the confidence scores are going to be quite close to zero. Some are going to, but it's a kind of an exponential decrease with increasing confidence score. So what I'm thinking of is to take, say, like the Humei detections that BirdNet has, which are each 3-second clips. So it's a 3-second clip that BirdNet has given it the Humei label for a given 3-second clip and a given confidence score. So what I want to have happen is to sample across those confidence score windows. So we sample some BirdNet identifications of Humei that have a low confidence score. We sample some that have a medium confidence score. We sample some that have a high confidence score. And we send just those 3-second clips to Pranav to listen to. So Pranav can listen to them really quickly and say, correct, correct, incorrect, incorrect.
Yeah, that makes sense.
Okay. So is it okay if we start from 0.5 or is it gotta be from 0.0?
We could we could start with 0.5 and up. It might be the case that that the 0.5 is still a very high one. I'm thinking through it. So when I've done this before, like the threshold at which BirdNet is making correct predictions, it varies depending on the species.
Okay.
But for Costa Rican birds, it was usually maybe 0.6 or 0.7 or something. Above that was high probability that it was correct. But there were a couple birds that even down at like 0.01 was getting it correct. So maybe to start with, I think it's still useful to sample across the entire confidence score window. But the issue is that if you randomly sample, you're going to disproportionately sample stuff with low confidence scores because most of the labels have a low confidence score. So to combat that, we need to like divide the BirdNet labels of Hume, for example. We can't just randomly sample from those. We have to divide those into, say, quintiles of confidence score 0 to 0.2, confidence score 0.2 to 0.4, confidence score 0.4 to 0.6, 0.6 to 0.8, 0.8 to 1, and then sample 10 or 20 from each of those bins so that all told, we're getting a kind of even sample across the confidence score line.
Yeah, that was going to be my next question is how many samples do you think Pranav should go through to be like significant amount?
Yeah.
But you're saying about 50 to 100?
Yep, I think so.
Okay.
So I've been doing this with so there's a trade-off between how much time it takes and a couple studies have come out that have done this for like 50 recordings or sorry 50 labels and then expert assessment of those or 100 for Hume. Maybe we should do 100 because but in my experience, Pranav, if you have like a CSV with the 50 or the 100 recordings and the confidence score, and you just add another column that says, correct or whatever, and you write correct or incorrect. If you have that CSV and you have a folder of those 3-second clips that pertain to row 1 is the first one, row 2 is the second one, and you can just listen to them, and it's in like the Hume song, so it takes half an hour to label 100 songs.
And we should send them blind, right? Like we shouldn't let Pranav know what confidence level they are. Like he should know
True.
what.
Yeah, that's a reasonable point. Yeah, that would be the ones I was doing, I knew the confidence score on but yeah, I think you're right. It would be better just to, I mean, you can kind of tell if you start listening to the recordings that have low confidence scores, they're recordings that like often have like just like they're poor recordings, like they don't sound good, whereas the ones that are going to have high confidence scores are like nice recordings of a bird singing. But I do think you're right that just to avoid the possibility that Pranav starts to get tired and he's like, well, this one has a low confidence score, so it'll probably be wrong.
We're really going to test Pranav, really see how good he is.
Exactly. We're going to see if he even knows what these birds sound like after all this. Okay, but yeah, that's what I wanted to bring that up. I'll write a little something right now that kind of delineates the methods of what I just verbally described, and I'll share that with Pranav, who can immediately share it with all of you. But I think essentially what I'm suggesting is let's start with Hume, and figure out how to kind of randomly sample 20 Hume recordings from each of these 5 confidence quintile bins, and then figure out how to extract those 3-second bits as a small audio file and share those with Pranav so you can listen just to those 3-second bits, because it takes way too long if you have to cross-reference and find. And I had written. I'll include something from a researcher who I had asked some questions about how to do that with, so I'll share that information with you as well.
Yeah, that would be helpful. You mentioned like the way that they fit the data to the confidence level, or how they decided what confidence level, whatever method they use, that'd be really helpful.
Yeah, well, that one, I think what we're doing is basically making a plot of correct or not correct versus confidence score. And when confidence score is 0, it's probably going to be not correct. When confidence score is 1, it's probably going to be correct. But at some point, we can fit a logistic regression to that data.
Oh, I see.
To get say at a 95% confidence, or no, sorry, 95% probability that it's correct, and we can figure out what confidence score links to that. And this paper I dropped in chat by the people who made BirdNet provides some simple R code to do that as well.
Perfect.
Sweet. Thanks.
So I'm gonna sign off, but this all sounds very cool, and yeah, I think once we are able to translate like I think anything above confidence score 0.8 is likely to be correct, but I'm curious to see, is it possible that anything with a confidence score of 0.5 is actually correct? If so, we have a lot more data that we trust. But either way, figuring out like kind of which confidence scores we trust will be an important step here.
Cool.
Yeah.
Thanks, Ben.
Absolutely.
Awesome. Did you already find out the way to sort of extract 3-second clips?
Yes, we already done just like what, half an hour ago.
Oh,
We've
okay,
done,
great.
but so we've done it only for Xenocanto and iNaturalist data. And why it's only these two sources, because they are only about Hume. So like we just try like to we cut this data and we use it for our training model. But as for confidence levels, yes, we can do it as well. I mean, the code is already in, so just like mm,
Well, I think we'd have to first run all the data again through BirdNet because we need all the confidence levels now, and then from there maybe randomly generate which
yes,
ones,
right.
and then from there we'll clip the specific thing. So it might take us a little time, Pranav, to send you the files.
No problem. Yeah.
But I think just off the top of my head, that might be the course of action for us to do for now
Sounds
to
good.
get those together.
Actually, we don't have to run all the data. We just right now, let's say we pick up random files, like random files, like say 10, 15. Let's say each elevation, like low, high, and medium, 5 files, and we run them starting from 0.1, right? 0.0, okay. And then we can work with those files. That's it. We don't
That's
have to
true. Yeah,
run all the files. We just can pick up random files right now. And
that's
then
true. We can still
when
do
we
it that way if that
pick
makes
them
more
up,
sense.
we cut them into 3-second chunks. It will be helpful for Pranav and for us as well. Yeah, so that's it. So in this case, we save our time.
Sounds good.
Yeah, I do like that. Yeah.
Okay. Yeah, there's no rush. You can take your time, and I can look at the audio files over this weekend or next week, because I still have 2 weeks here, so I can potentially have a good look at everything. And even after I'm gone, I'll still have access to internet in between, so I can download files and keep doing that work. So I don't think there's any problem with time as such.
Okay, perfect. And meanwhile, we also gonna send you the files for our training data, because in this case, it can be also like very important. We have to
Yeah.
train the model based on it.
Yeah, so maybe you should start with Humia then as an example. Then I think that will be a good idea to just start with Humia first, and then we can expand.
Okay, okay.
So you can just use those files to train the model because I'm already listening to Humia, so you can just use the same files to probably train the models.
We are using only Xenocanto and iNaturalist data. We're not
Yeah,
using your field data, because in this case, what we are going to do, we are based on our trained data, we are just go through all your field data and define where is the call, where is the bus, and where is the HumeAI is identified correct or not.
yeah,
So that's the main approach. So we can't use the field data right now, at least,
right. Yeah,
in training our model.
sounds good. Yeah. Okay. Um. All right. So that's about Audimod. How's camera trap work going on? How is video stuff going on?
The video stuff has been difficult recently. I think I spent a lot of time trying to get these transformers up and running, but then a lot of the problems between trying different models is that a lot of them like expect different data formats for the
Okay.
input. So I think we've been struggling a little bit with that. But and then like also now some of these models are getting really big, so we can't run them on our local machines anymore. So Kaushik and I both attended a PACE workshop earlier this week to try to get some guidance on how to get all that stuff set up. So I think we're in a good spot. I know Kaushika was able to get some results last week or 2 weeks ago they're definitely interesting, but I don't think they're to the like level of accuracy that we're happy with. I was gonna say, I don't know if you want to show anything or talk about that, Kaushika.
Yeah, I was just gonna hop in and say that I do have like a working model. I use like Hugging Face repository, tried a different bunch of different options, and was finally able to have a working model. But the thing is, like when we talked to our like computational advisors, they mentioned going with the temporal model, so like video based model essentially, and I thought that the model I found was video based, but it turns out it's not. So that's like an area like I can look into, like if it's not even video based and it's already like having like a baseline accuracy of this, then maybe like if I'm able to find a better model, then like that means there's always room for more accuracy, right? So like that's like two avenues. Also, like one is like to like keep trying to fine tune, but I feel like that should be approach B. I feel like since we know there are better models out there, that I should try to find like a actual like temporal model. And then since I attended the PACE workshop this Monday, like if the model gets too big to run, then like I also have that option that I can like start running on that. But so I do have a route. I do have like an approach as to like how to find a better model, but like there is a working model. It's not super accurate, but it does better than like a human would. But yeah.
Okay. Sounds good. I mean, there's no rush again, and yeah, take your time, figure out stuff. So no problem at all. As long as you have all the resources and all the help that you need, I think it's fine.
Yeah, I think I was gonna say I think we have all like the resources and help that we need. I think once we are able to find implement one of these temporal models and actually get results from the data we have annotated as is, we we'll have a much clearer path from there. But right now I think it's just getting some results from a temporal model. So
Great. As I said earlier, I'm gonna go in the field now and collect the same data again. So when I come back, you'll have twice as much data once I'm back for both audio mods and camera. So I don't think data will be limitation after this. So
That's perfect. Yeah.
yeah. Are you trying new locations, or are you setting everything up at the same spot?
It'll be same spot for the audio stuff. The nest locations will change a little bit because birds won't nest at the same place. So it'll be the same area, but the locations will change maybe like 10 meters.
Gotcha.
Yeah, but it'll be same recording, same stuff. Yeah.
Nice.
Cool. Is there anything anyone want to share more, or we can just call it a day? Oh, you're muted.
Yeah, send us pictures from the field.
Oh, 100%. Yeah.
That's it.
Yeah, I'll send the videos.
Yes, please take lots of pictures.
Yeah.
All my family keeps asking if I'm going to go out there, and I'm like, I don't think they do that. I think Pranav's the only one who goes out there. It's like I'd love to see it, but I don't think that's a thing.
Yeah. I already have done some pictures that I can share right away. But yeah, as when I go, I'll share the live pictures or whatever, the videos. That'll be
Yes,
cool.
please do.
Yeah. It'll be a bunch of snow when I go there. But I will have to wait for snow to melt and then sort of birds get in and then they start nesting once the snow is melted because they nest on ground. So they don't want snow.
Yeah,
Do they migrate at all? Do they move?
Yeah, they go
Oh, okay.
down south. They go in peninsular India. around central India and then migrate back like thousands of kilometers just to have like 4 babies.
Oh,
Yeah,
cool.
yeah,
Life is not easy.
yeah. It's difficult.
And actually, if you have a chance to get the technical specification of audio mods, it will
Yeah.
be interesting to know, just to know.
It should be out on the AudioMath website. I mean, I can look it up and share, but do you want anything that's from the field or anything in general?
No, just in general, like, just to understand, like, okay, I mean, they are all the same, right?
Yeah, yeah. So it should be on the AudioMath website. I can pull it up and share later.
Yeah, absolutely. So, because like, just when you are listening to the recording, so
Yeah,
you're able to catch like different birds, and
yeah,
the distance is it's very different. So like, my question is like, how far the audio mouse can capture the sound? Let's say it's
right.
like 5 meters or 10, because right now, I mean, in my case, I can't tell, like, it's like two birds, like what is the how far are they from each other? So,
Yeah,
and the point behind is like, just okay, if we see the radius, then we probably can also get some data insights. So I don't know.
right. So that matters a lot, based on a lot about what species we're listening to, because some species have really high frequency songs and they
Yes,
travel super long, like 500 meters, 300 meters. Hume's call is not high frequency, so it doesn't travel that long. But Hume's song, the buzz,
yes.
is a little bit high frequency. It just travels further long. So it depends which species we're talking about and the distance that it travels.
Yeah, yeah. So
Cool then. Thanks for the results are exciting. So I'm very happy to just look at what different species are there at each location. It sort of makes sense. But yeah, happy to take a look at the audio files once they're ready, and uh, yeah, I'll just go through all of them and mark correct, incorrect. So I think that'll be a good start. And I'll share what Ben has to say about this in a minute. With
perfect.
everything.
Thank you so much.
Okay.
Sounds good.
All
Thank
right.
you.
Bye. Thanks.
Bye.
See y'all.